Hello everyone, this is Navin Kumar. Today my topic is about a note on the entropy change across the normal shaft. And I am from Aero section and the subject of computational aerodynamics from topic. And today I want to discuss briefing about the normal shaft wheel and how it gets formed. As the object through the gas, the gas molecules are deflected around the object. And the speed of the object is much less than the speed of the sound, and which is equals to 340 meters per second or less than Mach number. Mach number is less than 1. So Mach number is equals to 1 and less than 1 of the gas. The density of the gas remains constant and the flow of the gas can be described by conserving the momentum and the energy equation. As the speed of the object increases towards the speed of the sound, we must consider the compressibility effect on the gas. And I want to describe the compressibility limit of a gas. And if the Mach number is equals to zero point 0.3, up to the zero point 0.3 and less than zero point 0.3, the fluids which are considered as an incompressible fluid, and as and the compressible, the Mach number is about greater than zero point 0.3, then the fluids are considered as the compressible flows. So, of the gas, the density of the gas is varies locally as gas is compressed by an object. For a compressible flow with a little or small flow turning, the flow is reversible and its entropy is constant. And according to the thermodynamics, so whenever the flow is reversible, then the entropy remains constant as uh, the change in flow properties are given by isentropic relation. Here, the isentropic means constant entropy, and isentropic. But when the object is faster than the speed of the sound, there will be abrupt decrease in the flow area. The flow the flow process is irreversible, and the entropy is increases. Shock waves is generated. The shock waves are very small regions in the gas where the gas properties can change large amounts. And across the normal shock wave, the properties like static pressure and temperature and density will it increases almost instantaneously. It is why because the here the flow across the normal shock wave with the Mach number is greater than 1. So when it passes through the normal shock wave, so the flow across these the properties like static temperature, static pressure, and static density get increases rapidly, and the velocity will get reduces, and the Mach number after the shock wave is less than 1, and for other shock waves like oblique shock wave and like expansion waves, they have in the oblique shock waves also the velocity get decreases, pressure get increases, uh, like density get increases, and temperature will also increases. But uh, the Mach number after the oblique shock wave is greater than 1, whereas compared with the normal shock wave, it has less than 1. And I want to discuss about the thickness of the sharp wave. Whereas if we go for the normal sharp wave, the thickness is minus 10 to the power of 9 centimeters for the normal sharp wave. And the normal sharp wave is formed uh, like perpendicular 90 degrees with the flow. The properties of normal sharp wave. Because of normal sharp wave does no work. There is no heat addition. The total enthalpy and the total temperature are constant. But because the flow is non-isentropic, the total pressure downstream of the shock wave is less than the total upstream of the shock wave. As coming to this total pressure, as we all know that Total pressure is same like as stagnation pressure, and the total pressure is defined as the sum of the static pressure plus dynamic pressure, which is less after the passing through the normal shock wave before and after. If we take before total pressure is is greater than after passing through the after passing through the normal shock wave. There is no loss of total pressure associated with the shock wave. So the ratio of total pressure is shown in the slide. But the total pressure changes across. We cannot use as usual in an incomparable form of a Bernoulli equation across the shock wave. The Mach number and the speed of the flow decreases across the shock wave. The shock wave is perpendicular to the flow direction. It is called normal shock wave. On this slide, we have the recent equations which describes uh, change in flow variables for flow across the normal shock wave. The presented were derived by the considering there are some governing equations which are used for the equations of used for uh, to find out the four parameters like a velocity, temperature, pressure, and density and temperature. We are going to use some governing equations like momentum equation, energy equation, and the continuity equation, and some of this equation of states we are used in order to find out the field variables like velocity, pressure, temperature, and gradient. So these are equations used in order to find the velocity and all the things which we required. So by considering the viscous effects, uh, these equations can be further classified into the one-dimensional force without an eight addition. Here, the normal shock wave occurs in front of a supersonic object in the flow. Is turned by a large amount of and shock cannot be remain attached to the body. Generally, this normal shock wave is the very strongest shock wave among the shock waves. This is occurred. Uh, this is act like a discharged shock wave, which will separates the flow as it calls as a discharged shock wave occurs for both wedges and cones. The normal shock waves is also present in most of supersonic inlets across the normal shock wave. Uh, for example, if we take the ramjet engines, then there we can see this normal shock wave where the Mach number get reduces less than one for a combustion chamber. It will be placed in the normal shock wave is passed in the like formed in the combustion chamber before combustion chamber and inlet in the inlet. Across the normal shaft, the flow changes from a supersonic to subsonic condition. Since the gas turbine engines operate under a supersonic condition, it is necessary to introduce a normal shaft wave in the inlet compression system. The normal shock waves are generated in a shock tube. A shock tube is a very high velocity wind tunnel in which the temperature jumps across the normal shock tube is used to simulate uh, high heating environment and spacecraft re-entry. Here we are seeing some of the relations for the normal shock wave. Uh, Here the P is the P static pressure and PT is the total pressure and T is the static temperature and TT is the total temperature and rho is the density and M is the Mach number. So gamma is the specific heat ratio. This ratio of Cp by Cv is equals to R and Cp minus Cv is equals to R like the adiabatic index. And coming to downstream, PT is the static pressure get increases and the total pressure gets decreases. The temperature gets increases. The total temperature will remain constant in the normal shock wave. Why? Because the flow across the normal shock wave is adiabatic. When the shock waves, when the flow get passes through any object, there will be less contact time. So there will be no heat. it supply between the object and the flow. So the flow across the normal shock wave is defined as an adiabatic flow, not an isentropic flow. So as you know, as we all know that the total temperature remains constant across the normal shock wave. The density gets increases because of these equations of motion, and the Mach number get decreases. And here are some of the equations like P1 by P naught is equals to, it is the relation which is used to find out the downstream pressure by using total pressure. PT1 by PT naught is, it is the relation which is used to find out the total pressure of an inlet like upstream and the downstream. If we know one pressure, we can find out the downstream pressure. If you know the upstream pressure, we can find out the downstream pressure by using Mach number. Uh, T naught, T1 by T naught. It is also one of the relation which is used to find out the static temperature before and after the shock waves. So the T theta 1 by T naught, T theta naught is equals to 1. Rho 1 by rho naught is equals to gamma plus 1 m square by gamma minus m square plus 2. This is also a relation which is used to find out the density after the shock wave and before the shock wave uh, when changes. Mach number. In order to find out the Mach number of the after the shock wave, we have a relation called gamma minus 1 by m1 square plus 2 divided by 2 gamma m1 square minus gamma minus 1. It is a relation which is used to find out the Mach number of a shock wave after passing normal shock wave. Thank you.